Hi, it's Gadget UK here again, back for the continuation of the 32-bit Amiga Repair-a-thon series. So we looked at the first two boards in the last video. One of them was the main focus. We just had a quick look at the second board towards the end of that first part there, and I think the way I left it, I noticed that there was you could press down on Alice. I'll show you that in a second, and it would spring to life. You can see this is my A4000 here. This is the one that I got from Stephen Leary and fixed myself. So yeah, this ended up a horrific mess here, but actually it's quite tidy and logical the way it is. You know, the two chips were stacked on top of each other. I had to have quite a lot of wires because I don't know if you can tell, all of the pads for the 166 there had gone. Yeah, you can see my nice Rev 11 Buster there. Anyway, I'll just have a quick recap of where we were at the end of the previous video. But when I press lightly here on Agnes, you will see, hopefully, look at that, it works. And it's detected the full 16 meg. And then if I let go, just let it get stable, look, watch, if I let go, straight away, oh, you saw it go weird, look, and it's gone. So we're back over at the mat. We'll do two things while we're over here. We'll remove the battery first of all on this one. I figure it's the first thing I should have done on that previous board, but let's do that on this board. Let's get it right on this one. The battery's barely hanging on. I think it's been replaced at some point, not fitted properly to be honest, because you can see these little blobs of solder. They're tiny on this side. It's like it's mostly soldered onto the other side of the board, which is never a good way to fit a battery. I think based on the fact there's very little solder there is on that pin, but these two here are literally, it's probably floating on the other side. We'll just try and gently pull it. Let's do that one first. Yeah, that one's out. I'm not even sure where it's soldered on actually. I think it's that one there. Yeah, there we go. So, awful battery off. I'll do the same mod that I've done on a lot of these boards before to both of these A4000, which is to fit a Schottky diode or low forward voltage drop. Now the company that sent me these included some CR2032 holders as well, so yeah, it's going to need recapping again. The caps look crusty on this one. So the other thing I was going to show you, and I'm not sure this is visible here, you can see this pin. It looks a bit dark, the pad. What happens when, and even these two here, when you get a little bit of electrolyte somewhere, you find that it gets under the pin. It detaches the pin from the pad. So this is perhaps why when we press here, it starts to work. But it might not be. It could be something around here. It could be something further into the board. But I figure let's see if we can nail it just by inspection. So I'm going to reflow that. Reflow those two. No, in fact, I'm just going to reflow that and test it. If that doesn't work, I'll reflow those two and test it. Let's just get a tiny bit of flux down there if we can. Yeah, trust me, there is a little bit of flux there. It looks like there isn't. There is. I'm going to go get a new tube in a minute. And yeah, we'll just have a go at trying to resolder that pin. I can smell straight away and see straight away that has got corrosion on it. That is the problem. It's very hard for me to see what I'm doing here actually. If I get a big blob of solder, I'm not too bothered. I just don't want to join. So I just retested it. It's exactly the same. So nope, it's not that. So let's just get a little bit more flux over here and do these N2 pins. As I say, when I've nailed it, what we'll do then is get flux all along here and reflow the whole side. Might even go around the whole chip. What we can do is look at the pin out and work out exactly what that signal does. Got to be careful because I'm going to end up bridging these, aren't I? I've got a complete wrong tip for the job here. I really need to use my other iron. But anyway, we should just be able to reflow these two pins this way carefully. Just for the purposes of testing and working out. Right, I'll inspect that and then we'll go and test it again. Boom! Nailed it pretty much. We've still got some weird things going on there, but it would seem it is those connections, I think, on that side. Oh, we're still getting some. Let's just try and press. Yeah, it's definitely something around there because, well, you can see it's a lot more stable after having reflowed those. So I'm pretty sure it's around Alice. So I'm just going to get some flux around Alice and we'll solder all around it. I'm using the extractor fan from ZX Kim here. He's still in hospital as far as I understand. I've not heard anything. He's had COVID, so I do hope he's making a good recovery. So I've repositioned the camera there. I can't show you everything because obviously I'm going to have to rotate the board around and stuff. You can see the jumpers are in the way here, but if I just get a little bit of solder on there, I'm using this tip deliberately because I just find it's the best thing for this kind of job. You know, you can drag solder if you've got enough flux there. I'm going quite slow because, well, A, the iron's not heated up, and B, it's a bit cold in here, and C, these types of pins, if you've got a crap iron like this one here, they absorb an awful lot of heat, especially if you're heating more than one pin at once, as I am here. So yeah, when it gets a bit warmer, I'll do a bit of that, you know, just drag along there. I've got to be careful because I'm going to melt that jumper if I'm not careful. So I finished the soldering. I used the cotton buds to mop up the majority of the flux there. I'm just using some IPA brush now to have a nice scrub around this whole area here because it's been very fluxed up. And then I can inspect the solder points there, just make sure I've not got any bridges that I've introduced, and that everything looks okay in general. Right, let me inspect that and we'll go and test it again. There we go, worked first time and it's totally stable. So we can now test out everything on here. So I'll test the fast memory. So that took ages, but 16 meg has passed okay. You can't get back here, I don't think. This is the problem with this test. You may be able to if you press a keyboard, I don't know, escape or something. Anyway, let's go back round again, let's test the chip mem next. And you may be thinking, why test these? These are sims. I'm using my 2 meg chip mem, and I'm using 3 of the sims that came with these boards and 1 of my own. We're not just testing the memory here, we're testing the actual interface to the memory, you know, the sim slots and all of the stuff that sits on the board, the CPLDs and, you know, GALs rather, and Ramsey, you know, hang on, let's do memory tests. Extended chip mem. Yeah, so I'll let that go around. As soon as that 2 meg is okay, I'll move on to the audio. Ice cream, anyone? And there we go, all 2 meg of chip has passed. So let's test the audio next. Go back one, audio tests. Now it does need recapping, so it wouldn't surprise me if the audio was problematic here. But it is actually working, isn't it? Let's test the filter. Yeah, I'm not sure if you can hear that. I can hear a difference. The filter test on test kit, you know, sys test or whatever it's called, sys check, is better. Let's do module. Yeah, that's working. Let's test the CIAs and IRQs. IRQs are okay. CIA timing. I think there's going to be nothing very much wrong with this board now other than needing a recap. So if this passes, I think the next thing we're going to do is we'll connect up the compact flash card, test IDE to make sure it can identify the IDE, you know, compact flash card, and if that works, I'll connect up with the original Kickstart ROMs and the Zorro. I think I'll get boot on there and see if it'll boot from SCSI. Yeah, it's booting every single time now, so it definitely was those solder points around Alice. Alice is your equivalent of Agnes on these AGA boards, by the way. You know, it contains the blitter and the copper and does all the stuff to do with memory. You know, I think it's got some DMA functionality, hasn't it? So we're going to drive tests, we're going to Gary IDE. There we go. Spotted it first time and it's got the right things there. Rev2.35 CF card. That's exactly what this compact flash card reports and the geometry is correct. So let's get my CPU card off. This is the one I covered in a previous video where we fitted a Freescale, a full 030. Yeah, the solder points and the legs don't look quite as good as I would have liked on that, but the chip had been reclaimed. You know, the seller said it was new, and it wasn't. So we'll get my Diag ROM out. The interesting thing with my Diag ROM chips is they come out really easily. It's a little bit weird. It's like other chips in these sockets are more resistant to going in and out. It could be the solder, whether there's solder on the legs and things, you know. Oh, this one's always a pain because of the IDE and the power cable. I can get that side out first, and this side becomes somewhat easier. Someone's bound to say, why don't you get a chip extractor? I will get a proper dip one at some point. And I don't mean the ones that just got thin prongs and you try and pull them, because those end up damaging pins more than anything. I mean the ones where you've got like a button, a lever or something, you press a button down and it pulls it, but you've still got to hold it in exactly the right way around. So I am a little bit confused as to which one of these is which here, actually. They've both got the exact same. Oh no, that's one that's got 3 on, and that's got 4 there in the code. So let's assume the 4 is the upper. I bet these are the wrong way around now. Let's find out. See if it'll boot. Pin 1 is towards the top here on these. Kickstart 3 this. Yeah, let's get the CPU card back on. Lift the board up and squeeze it on. And I think they ran the wrong way, to be honest, because that's the thing, you just get a black screen, because it's just not going to do anything. There's a chance the ROMs are wrong or bent a pin or something, I don't think so. Anyway, I'll report back in a minute when I've swapped them. Right, I've swapped them around. If we watch the LED there, hopefully, it might start to boot. Yeah, it's booting now. You saw the IDE flash, then it should flash again in a second. It pauses a sec while it looks for floppy drive. There we go. Booting. Sweet. So I think, other than the floppy interface, serial, parallel and real-time clock chip, got to test those things yet, it's 100% so far. What I'll do next is disconnect the IDE, connect up the Zorro, and boot it from Booty McBooterson. There we go, so it's all a little bit topsy-turvy here. I've got a disk box just holding this card up here. I've tried powering it on just with a bridge board on initially to make sure it's okay, and it is. Because that bridge board is part of another repair. Actually, I've got another A4000 coming soon to the channel. If you keep your eye on that LED there, that's the SCSI LED. I'll switch it on. So we get the flash like we did on the other board actually, but then the other board was not booting from SCSI at all. Now there'll be a delay while it looks for the IDE, and then if this is, there you go, if it's working, it will start to boot from SCSI, and it has done, I think. You get another delay, there we go, it's booting. There we go, sweet, fantastic. So the Zorro is okay, and we've got 18 meg of the RAM there. If we go into some of the utilities here, let's have a look. We can have a look to see what boards report. Go into sysinfo. I think you can see the boards there, can't you? Yeah, there we go. So we've got the A2091/A590, and we've got 2 meg of fast RAM with that as well. So I'll leave that doing the time gal test for a little bit, just to make sure the Zorro is stable enough over a period of time. Bear in mind we don't test everything with Zorro here. There are functionality that this card is not going to use, you know, the bus mastering stuff and all that kind of thing. I would need some decent Zorro 3 cards to test that, so I can't fully test these, but I'll be honest, it's unlikely to have an issue related to that specific piece of functionality. You tend to get a problem where, you know, the bus transceivers are the issues really with Zorro, more than anything. So the replacement budget has arrived, so I'm just going to get a little bit, not a lot, of flux around this. I've used so much flux on these boards, and the thing is I don't think I'm getting part money, you know. I don't think I'm going to get paid for parts and things on this. The way it's worked is there's going to be a load of CIAs. I'll show you those later. I've not even had a chance to look at them yet. I'm not even sure how many there are, but anyway, I did offer to look at these, and you know, I'm kind of interested to resolve these anyway. I'm not sure I want to do any more moving forward. It's just too many. Before I commit to doing any soldering here, let's just get a little bit of Captain Save on here, because you know what, I don't want to risk We're not really near it, but I figure let's just captain tape those two things off there. I'm just reusing some old tape there, it's got some hairs and things on it. That I'll bin that after we've done this, and let's just proceed to try and get this off. Let's just get that off there. Let that cool down a little bit, get the pads cleaned up. No, we didn't lose any pads there. It's a bit of an optical illusion. So yeah, this pad here, it's not in great condition, but that's the one where I say the pin was smashed off. So here's the new chip. You can see it's in this sponge here. I need to pull this away from the pins here on the sides in order that we can gently lift it. There we go. Just carefully get that on there. So you've seen me do all this sort of stuff before. Make sure you wear an NESD wrist strap. I am grounded at the moment, and we'll just get that into position using some magnification. Make sure it's aligned on all four sides, and anchor a couple of diagonal opposites, and then drag flow on the sides where you've not anchored it. So I'm going to try and do this without magnification. The key is to inspect before you commit to soldering anything else. Got the jitters on this right hand. See, I think I just moved it then. Let me just inspect that. No, I didn't move it there. I've just anchored it there anyway. Gives me an opportunity to do this one on camera here. Just try and get onto the pins there. Doesn't matter if you do 2 like I've done or 3. The key is just to press it. So I just need to inspect now, and then we'll get some flux around it and drag solder. Let's just start in the middle. You can see I'm kind of dragging along but also dabbing in and out here. You see we're getting bridges there. The iron is not quite at the high enough temperature here. That's one reason I like to use this iron though. It's a lower power, so you don't sort of overheat things. Anyway, you can start to see down this side it's looking okay. There's more work yet though. Let's get rid of that solder. Let's now try a slow drag. The reason I'm going slow, as I say, is this iron is not very capable in its thermal. You know, the amount of power it can dump into the board is limited. So we've got a little bit of solder there. We can move that with some braid in a minute, but you get the general idea. Just do the same on the other 3 sides. Use the braid to remove the extra bits, then reflow just to make sure there's enough solder on those bits where you've used the braid, and we should be good to go. So we're all soldered on. I'm going to clean this up before I test it, because then I can use magnification, not get hindered by all the flux around it affecting the visibility, and we should be able to see nice and clearly whether anything's bridging and that sort of thing, you know. I don't think so. This side here was the hardest, funnily enough. You'd think it would be the inside one here. That wasn't so hard. I can remove that tape now, look. And that piece from over there. So I'll get some kitchen roll there, tilt the board like that, clean it with a toothbrush and IPA. Oh, there's a cap here moved, can you see that? That must have moved with the hot air. I'm surprised at that. Maybe it was hanging on, I don't know, I just see it flaking around there, wobbling in the breeze. That one's alright. Let's just see what is going on with this here. Has it just come off there? Yeah, it must have come off with a hot air. It must have come off with a hot air, because the pad is there. Actually, the cap's bad. Actually, the cap is broken. I think the top of it is here. This might relate to the impact that was here. Let's just take that off. We can replace it. Yeah, that side there looks broken. Anyway, those aren't joined. It's just a decoupling cap. We can replace that later. Right now, I want to inspect around there and test it. So I think we're a step closer. We're getting a yellow screen, actually. But unless you remove the SIM, let's just do that. If I remove the SIM, I've not got a 2 meg SIM, I'm just using the 1 meg SIM. So without that SIM there, just watch. Oh God, what is going on here now? Green, then red. So there is something else on this board. I'm thinking maybe the real-time clock actually could cause this. I've seen similar problems on boards in the past. But anyway, the bridge is not getting hot. Most of the time when you switch it on, you get a green screen, which is normal. Yeah, green, but then red. Now that could be because these are not here at the moment. We're getting either yellow or red after that initial green, which it might not be that. It could be something else. It could be like the RTC interfering with the data bus a little bit, and it's only causing a problem after a few seconds. But that's not getting hot. Before it was. In this right hand corner here, it was getting really hot before, super hot. Now it isn't, even when it's sat at a red screen. It goes green, then red, green, then red. It's just a bit weird. So yeah, it could just be the lack of these, or it could be some damage further into the board still yet to resolve. But I'm guessing if we get these back on, fingers crossed, we should have Zorro back again, but we may still have this weird intermittent yellow and red thing going on. I hope not. Right, that's good news. After refitting those 245s, Bridget still isn't getting hot, but we're just getting a constant green screen with no chip RAM. No black screens, no red screens, no yellow screens. So yeah, that's something I've learned here. I don't think I ever noticed it when I was looking at other boards, but I do remember when I had the problem with Ravis. I think I had those chips off at that point, and I was like, oh, is that the problem? And I think it is. You'll get a yellow screen without those on there. So right, I think the next thing to do is get a full complement of RAM in here, get the IDE connected up, and get the Zorro bridge board and get, I don't know, the A2091 boots in there, see if that'll boot. Right, I think I know what the answers with this, and it explains something to do with Ravi's repair, the Ravi A4000. Do you remember I was getting a yellow screen? The problem with the yellow screen is my CPU card. I kid you not, there's nothing wrong with it. I fitted a crystal here, 50 megahertz for the FPU, and you know what, at the time that worked. Depending on the weather, dictates whether this can actually run at 50 megahertz or not. If you try and overclock a 6882 and it doesn't like it, you will get a yellow screen on boot. I'd forgotten all about that. That's something I learned when I was testing some of these on an A2000 in the past. So I'm going to drop that back down to 33, I think, or 40. It doesn't really need to be that high anyway, so a lesson learnt there. Just temporarily I've moved the jumper over here so it's using the motherboard frequency of 25 megahertz. So that was the mysterious yellow screen issue. Now, how did I come to that conclusion? What led me to work that out? Because I tell you what, I have been round in circles with this particular board and the yellow screen. A friend on Discord, one of my patrons, mentioned the delay line. He says, it's not your delay line, is it? So I thought, oh, I never thought about that. These do deteriorate, and because it's a delay line, your clocks can kind of go slightly out of sync. Your 90-degree phase shifted clock can be more phase shifted probably as a result of an issue there. So anyway, I swapped these jumpers here to external, and I tested with this, and the yellow screen went away. So yeah, this morning I was going to consider swapping the delay line. I thought, well, before we do that, let's just rule out that it's not something specific to this card, because that's the other thing here. It's not just we're switching over from using the delay line here to, you know, clocks coming from this board. And I'm glad I did, because yeah, that's what it was. And I even tested it on the other A4000 board. Lo and behold, that's now yellow screening with this card as well. Well, it's not now. Now I'll switch the jumper over. So that's that. Now back over to the Zorro issue. Zorro is still not working on this board. The Bridget is nice and cool here. That last one, you put your finger on here, about 3 seconds after boot, it started to get really hot, like so hot you could hardly keep your hand on there, your finger rather. So I do think the Bridget had failed on that previously. I'm going to send him back the old one and just say question mark. I actually not sure, because it's a different manufacturer. Maybe that the one just runs really hot. But yeah, things that get hot generally, unless it's a processor or an Alice chip, you wouldn't expect them to get hot so soon after boot up. So I swapped these 245s here. I've got some new ones coming. This one is one that was tested, known good off another board, but that one's brand new. So I need to clean up the solder points around there, remove the flux and all that sort of stuff. I even ordered some of these just in case, because 3 of the pins there, not sure if I've showed you, I reflowed them because they were green, they were corroded, and it just looks a mess. Anyway, waffle aside, I took Buster out, re-inspected around here again. Couldn't see anything wrong, but I've just looked under magnification. I'm going to have to put you on macro to see this. And I used my superfine probe here, and I've just gone down each pin and just touched them to see if they move. And lo and behold, the corner here, they all move in this corner. So I think that's perhaps the final issue with why Zorro is not working on this board. Fingers crossed if we can reflow those. It's going to be a bit difficult because the socket base is still here, so if I use my superfine tip and get some flux on, I should be able to reflow those 4 or 5 connections there. That one seems solid. See that moving? That one's moving. Watch this one here. Yeah, I'm not sure I can see that moving, but trust me, I checked some of these here and these were moving. Or one of them was. It might be these ones all down here, I don't know, let's just test that one. Yeah, that one's definitely moving. But anyway, I'm going to just double check which ones need soldering here and just reflow the ones down here. Oh yes, fantastic. I am so pleased with that, that's brilliant, brilliant news. So let me just try and boot that now. It should, in theory, boot from the SCSI, I think. It's going to take it ages to boot on this because it's designed to work with the 24-bit RAM, the A2091. You know, when I say 24-bit address range, I mean the Zorro 2 DMA. And because this has got Zorro free RAM in it, it has to drop back to PIO. I want an A4091 at some point if I can get one, but they're so darned expensive. Oh yes, fantastic. So that means other than the real-time clock and a recap, this board is fixed. It's got 2 meg of other mem there, so it's detected that. I've not got the 16 meg in the motherboard at the moment, so yeah, brilliant, absolutely fantastic. Let's give it the time gal test. Yep, that's working. I think it's just a bit quiet there. It's very quiet actually. That shows me that the audio section is bad on this, but hopefully a recap will solve that. To see the volume there, that would normally be about level 20 or just under, so yeah, it's 50% as loud as it should be. So I'm going to do a couple of things here. I'm going to remove the solder on that side there with some braid and reflow that. I'm going to reflow that because it just doesn't look that great. Yeah, I'm going to reflow that as well actually, and then we'll remove all of the flux and stuff off there. So with these 245s here, you may think, well, the original ones would probably be alright. I am not so sure, because one side of Bridget, and I think it was the side that relates to Zorro, I think had a fault there because it was super hot. This one doesn't get anywhere near that temperature. by a long shot. It's like 10% of the temperature of the other one that was on there. Yeah, anyway, it's probably a good idea to swap those out. Even if the original ones were okay, I'm going to bin them. I'm not going to recycle them after knowing that we had a short on one side of Bridget here. If you just listen there, I'm not even touching the board. That's the board level. There's a piece of the cap still on there. So yeah, I think that's related to these damaged pins here. Whatever's happened, this has had an impact around this area of the board at some point in the past, perhaps when it was in storage or something, I don't know. Anyway, let's try and give that a reflow again. Let's just get a little bit of solder onto the tip here. We don't need a lot because it's already been reflowed. Hang on. Yeah, I'll inspect with magnification, but that's looking pretty good actually. And as I say, for good measure, we'll do this one as well. But with this here, I want to remove the solder from these pins here. I might even take this chip off yet. I don't know. It's just had some really crusty corrosion just around those pins there. Anyway, it's not going to do any harm just to remove that solder and put some fresh on. It's mainly those pins there. That's cleaned up quite well actually. I'm surprised how well that's just cleaned. I'm not liking the look of the solder points on these, to be honest. Certainly on the new chip there, it's a bit weird. So let's get that cap replaced there. It's just 100 nanofarads. I've had a look at the schematics. So there's, yeah, look, a bit of it there. There, you can see it on the tip, of the iron. Flicked it off there now. Let's just use the braid here and mop that up. There we go, and do the one down there. Hang on. So let's get one of those on there. I'll just get it in roughly the right position down here. Add a tiny wee bit of solder there. Could always just move it with some hot air or something. Might do that. Yeah, that's not too bad. It's perhaps not as straight as it could be, but it ain't bad. That's all we need. Tiny, weeny, little bit. Yeah, I think agree. That doesn't look bad actually. And there's the bit of the old cap there. So a final look at that area, you can see these are all looking nice now. There were 3 here that were terrible. They were hardly joining the pads because of how corroded they were on the end here. Those have obviously been swapped, and obviously this has been swapped as well. So yeah, solder points not too bad there. So we removed the real-time clock earlier. I can just now use the fiberglass pen around here, and I'll get some vinegar onto it as well. The one I'm using at the moment is, I mentioned this, some of these are really abrasive. This one isn't. It's like really soft. Got to press really hard to get any kind of friction with it. It's weird how these vary so much. And it's not even doing anything that, apart from smearing the dirt around. Yeah, those are coming up a bit cleaner. Gonna go over that with some vinegar. Yeah, there we go. It's coming up a lot cleaner now. Yeah, hopefully you can see how much better those connections there are now. When we come to solder the socket, the solder's going to flow really well, and there's no contaminant there joining anything up. I'll pull the resistor pack off as well and clean the pads up there. I'm just going to try and tin this up here. It's not that important, because as long as you've got a good connection on the you know, to the real-time clock, we haven't done the battery mod yet, that's all you need. So these just literally serve no purpose. So my camcorder's getting on its last legs. I need a new battery and they no longer sell them. It keeps cutting out all the time. So you can see we tinned up the traces and things here, and these wires and everything around there. It's all looking clean, and even managed to do the connections there, although yeah, the PCB is marked because the corrosion has damaged it. Anyway, I've got a socket here, so we can get a socket on for the real-time clock chip. So the socket is nice and straight. What's going on with that solder? Really weird that the solder wasn't melting. There we go, that's our socket back on. I've cleaned the resistor pack here with the fiberglass pen. It needed very little work, that. So it's got pin 1 marking here. You can see that, they're kind of bent all over the place. They were like this from the factory. They do bend these to get them to stay in position, and that's ultimately, I think, what had been done. So if we straighten them all up like that, and then I can go up and down the profile like that. We use a little bit of braid on these before I get this into the socket. And you don't always need to use braid, you can sometimes just go up and down them like that on an iron with no solder on the tip. And you'll find if there are any blobs, they kind of get smoothed out. The third and fourth connections on the resistor pack, I need wires. So as you can see, I've got the wire there, and I'm literally just going to feed that through. Oop, flew off there, hang on. Yeah, I kind of pole vaulted it then, hang on. That wasn't what I was intended to do. I was going to put it through the hole, just sit it there. Do the fourth one, put it through the hole, just sit it there. Then get our cleaned up resistor pack. We can kind of pull these down a little bit just to bend them, straighten them out. Push it in. Just make sure none of the wires are exposed and they're not. And then if we just hold it all in place, flip it over, and just solder that into position. Yeah, that will look better when it's all cleaned up. But the main thing is, you can see they are joined on there and there, and I can just you know, cut these wires down and solder them into the relevant pins on there. And we can just solder them to the relevant points here now. So the real-time clock is fixed. I still need to clean up a little bit around here. I replaced the chip again. That didn't make a difference. I realised that some of the wiring here was wrong. That didn't make a difference. What else did I do? I removed the resistor array and resoldered it back on. Now you can see I've not finished cleaning up here. I need to get some IPA and maybe reflow one or two of the points. You've got a big looking point there. So yeah, reflow these points here. I need to tin up these properly, these three connections here. They're okay on the other side. But you can see we've ended up with a wire from the corner pin of the real-time clock chip to over here. I could shorten that wire just a tiny bit. I might just secure it with a tiny couple of blobs of hot melt glue or something. But ultimately, let me show you. Because I'd tested the connectivity all around here and I knew all of this was good, it was driving me nuts. But anyway, I looked at the schematics and thought, well, there are three signals that come from Fat Gary. You've got a read, a write and a latch. and if I show you these, hang on. So on continuity test, the second pin on this bottom side of Fat Gary here, I think that goes there, that's right. You see that second pin up from the bottom left on the real-time clock? Let's do that again. Yeah, there we go. And the fourth one, this is the one that was missing, goes to this pin down here. So that connection there was not occurring. I had to follow it all the way through the wires and things, and worked out it was between the wire there, which is really weird. That's a weird failure, but anyway, that was the issue. Maybe that was the original fault before the battery and capacitors leaked, I don't know. So the third pin down on Fat Gary there on the right hand side of it should go to the latch there. You see that? That corner pin. So that was okay, that was in place. So the damage around here, you know, this was missing on this board to start with. There was the wire from here to the first pin, so I've just bridged it with a little bit of wire there. I might just redo that in a minute. It's just literally a bare wire that goes from the wire there to that first pin. It's at an angle, it looks messy. These two don't look too bad. And then we've got one there that goes to, you know, where the trace was missing, and one there where the trace was missing. So whilst that other board has been on test for an hour and is on at the moment, you can hear it. I'm just going to clean up around here, so we use the fiberglass pen. This is really superficial. Now, the real-time clock doesn't work. I think it's just the two traces on here that are near to the real-time clock battery. That's always generally what happens on these, but anyway, we'll just clean with the fiberglass pen, and then I'm going to reflow these. Going over it a number of times because of the corrosion. Anyway, I need to rotate the board to do this side here, but anyway, I'll report back in a minute. Right, so let's clean up now. This bit here, we need more braid on it, we need more flux on it. So it's looking a lot better there now. So I don't really want to interfere with this, but you know what, we've got to. If we don't deal with this, I mean, it's superficial, it's not too bad. I think cleaning is going to be enough here. You know, the wires are not green down there. It might look like they are, but they aren't. It's got away very lightly, this board, compared to the other one. I will get my scratchy tool onto the tops of these wires here just to get the, because the solder filled these generally, it's just like contamination on the top. Yeah, this is not going to be easy because the solder is pretty corroded there. Make sure I don't touch the SIM socket. Oh, I can smell cap electrolyte there. That's not battery, that's from the cap. That is not melting at all. So let's try that again. There we go. So I've decided to take that off actually. The corrosion around that is much worse than it was down here, for sure. And then it'll allow me to clean these pads and wires and things and test underneath, because you never know, some of the wires under that could be not great. Anyway, we've got some flux around there. I'll just heat it up. Feel a bit of movement there. I don't like it when that happens. That's it. So I don't think we lost any pads there, that's good. So it did take me a good 15 minutes or so to clean up that, but can you see now? Look how clean those wires are there, and the traces going to them. So that was well worth doing. Yeah, far better. Looks new there. So I'll just test on continuity to make sure all these pads are going to the respective wires. Right, cleaning up now. I've reflowed around these resistors here, tinned some of the wires, got that chip back on, reflowed everything around there that's relevant. I will take off the resistor array and the real-time clock chip later, I think. Might not need to on this one, I don't know. To be fair, the corrosion has been quite contained, as I say, so I think we'll get away with it. I think it literally just needed a reflow, and that one wire there, I'll show you in a minute. Yay, the real-time clock works. It was just that one trace on this board, so I am very pleased with that. Let's just do reset. Yeah, there we go. That is working. So the next thing I'm going to do is get the battery holder on this. I didn't show you on the other one, I fitted it on the other one, and the diode. We've covered it in previous videos, but I'll just briefly skirt over it so you can see what is required. And a quick test of the memory before I do that battery as well. You can see it's detected 16 meg, and indications are that's okay. If there was a problem with that connectivity wise, it wouldn't get to 1.2. The positive side, that's this one here, wants to go to one of those three there. I need to make sure they're all joined on the underside. I'll do that in a second. And then you can see the negative. If you were to fit it here, look, it's interfering with the SIM socket, so you've got to fit it like that there, which means you've got to extend this leg to go under there. So all I've been doing with this is just join a wire. I use a resistor leg, solder it on like that, and bend it out, feed it through, and then join it on. You could argue it's a waste of a resistor, but anyway, yeah, so you could encapsulate that, but there's nothing to make contact with on the underside anyway. And then it's a case of trying to make a connection from either side. It's not the easiest thing to do, this. So I've just pressed that down and trying to move it inwards so that the edge of the socket is flush with the board and it's up to the socket there. And if we just flip it over and hold that, you can see we've got the terminal here and we've got our little wire there. Yeah, so testing from positive there, you'll see we've got a join to that resistor. So it's this third one along from the left here. We want to take that off. So we'll just bring the iron in and get some solder on that side, some solder on that side. Try and heat both sides like this. My iron really isn't the right iron. In fact, let me just swap to the Antex. It's got a nice large tip on it, as you can see. This just makes it a bit easier using this tip. So if you heat both sides at once, there you go, you can sort of start to get it off. There you go. Just flip that onto the mat. Just get a little bit of flux on here and we can reflow those. Get the solder off the tip and just bob into them like that. You can see we'll remove the excess. In some of my videos you'll notice that when I've reflowed these they look quite large, and this is the technique I've used, and I've not always shown it. I think Cather's board was a good example where when I was replacing things and stuff on it towards the back end of the series, it looked like I'd left really large blobs of solder, but I did this exact process at the end, but I didn't capture it on camera. And if you do that, they will look like factory. Still a bit too much on that there. Yeah, there we go. That's not too bad. So I zoomed you in a bit there. Let's just get the solder off these two pads here. That's one. That's two. Yeah, there's still a bit too much on that cap there. Got a 0.125 volt Schottky here, and we need to cut right next to, got that shot off, the component here. We're almost turning this into an SMD component, and we want it with a band upwards that way. And the way I try to do these, because it's not really the right component here, is get a blob of solder on that side, quite large. Try and use my tool here just to help me assist get this onto that one pad. Yeah, that's alright. And then do the other side. Again, quite a large blob because the leg is stuck up somewhat. There you go. Jobbers are good one. So what that means is the side down here, the anode, is connected to the positive, and the cathode goes to the real-time clock supply rail. So there's no chance of the motherboard charging or trying to charge the 2032 button cell. It really is that simple. So I've skirted over a lot of the recap work here. The ones with the red dot are the ones I need to remove. So we're onto this 10 here. I've done all the 47s on this board. The other board I've done everything apart from the 22s and the 4.7s. That's because they sent me the wrong capacitors. So yeah, add a bit of solder to each. Shown this technique before, covered it on MainMeister's CD32 repair. I'll stick a comment or a link rather at the top right and in the description below. But if you just heat both pins like that, pull it off, no problems at all, that easy. While we're here, we'll get rid of this. We'll get rid of this one as well. I've got a 100 to go back on here. There's a lot of corrosion around here. You can see I started to clean up a little bit. I'll do a little bit more before we fit the capacitor, and this is so corroded down here. Solder is not flowing, so some additional heat and time may be required. I can smell a fishy electrolyte smell. That one's really leaked badly. You can start to see it rotate a little bit there. Look, it's the side, the right side there, it's not very well. There we go. God, it stinks. Super fishy. I think we've got a mark in the board there where I was trying to heat it for excessive amount of time to get the old cap off. Anyway, that's okay I think, so get a replacement, it's 100 there and a 10 up here. Let's just clean the pads there. Now, despite how long it took me to get that 100 off, these have not took long to recap actually. Pleasantly surprised, A4000s. If you use the 2 irons technique to remove the caps, it takes no time. I'm talking like half an hour from start to finish for everything. So that's our 10, trying to see which way the angled bits are. I think it goes that way around like that. So yeah, the way I've been doing these now is not faffing around so much like I used to do, it's just literally get it into approximately the right position so that you can see a pad that we want to solder on. So here we go, that will do. Heat the solder and the pin and the pad at the same time, and then just manually move it if it's not quite in the right position. There we go, that's not bad. Yeah, that'll do. And then just come around the other side and solder the other side. If you get a funny shape, add some dedicated flux afterwards and reflow it. So it's looking pretty dirty under here, and that cap there looks like that has been replaced at some point. It just doesn't look that clean and tidy. So we'll just reflow the solder points on that with a little bit of flux. Got giant blobs of solder on that, which is a bit weird. Maybe it did fail and was replaced. Anyone want ice cream? It's not very straight, is it? But anyway, that will be fine. I will toothbrush all of this area here because it's looking a bit dirty in general. This whole area look very dirty. So something I'll point out, when doing this area here, there was lots of electrolyte all around here, so I removed the crystal. It was very hard to get that out. I think the electrolyte got into the socket there, so I soaked a bit of vinegar around there and into the pins and things. Cleaned it all out with IPA, and then I used a little bit of deoxit on the 4 crystal contacts and made sure that the legs on the crystal were super clean. I used the fiberglass pen just to wipe around the legs at all different angles. So it's important to go and test that now, just to make sure that crystal has made a good connection with the socket. And the other thing worth pointing out is I measured the connections between the pads and the wires here and the 7.4 series nearby to make sure that the ground and the VCC on these cap positions here were okay. We need to replace these ones here, but I'll do the same thing. I'll measure the voltages and stuff around here to make sure everything's correct once we've got some replacement for these. So this one has been tested over the weekend. The battery's been on there for about 4 days now. It needs a cap put in here. Can you see that? There's no cap here. I'm going to do that in a minute. The reason it's not there is because one of the, it needs a wire through one of the wires, because that one has got damage in that area, and there is still the little tiny little ones on the audio section in particular that need swapping out, but all of the main ones have been swapped out on this. That's the correct time and date there. So I'm confident that everything on this board is solid. It's had quite an extensive test with the Zorro. Tested serial ports, parallel ports, floppy drive, mouse, joystick, IDE, everything. LEDs as well, the power LED, the disc LED. So yeah, I think this one is good. I just need to go and get that cap on, and then we'll test the board. You've just seen me doing the capacitors on. So the wire that goes to the cap on the inside here is completely corroded through. So I've just drilled it once with a very fine drill, but I'm not doing the thing where you're supposed to push down on this, because the drill bits that are in here are very fine and they can't withstand the pressure. So I'm just literally twisting. There we go, straight through. And I'm just going to do that again, because this will make the 3rd time. This is slightly bigger than the previous drill bit. Yeah, that's clear now. But I couldn't even get a piece of kynar through there. There's lots of flux around here, and I haven't finished cleaning up this area yet either. There we go, it's going through now. So I'll just extend that a little bit, like that. Because what I want to do is solder it on this side here, and in fact, let's prepare that. So in order to prepare this, I need to just gently scratch the surface of that wire there. Can you see it's gone silvery? So there was a little bit of solder there, but it's just covered with a bit of flux. And if we feed the kynar through there, all the way through, on quite a long bit, just bend it down so there's enough to solder onto here. This one always tends to need to be done this way, this cap, because you do generally, when it's corroded like this, you lose the through hole. Yeah, I've got a little bit of solder there. I'm just going to trim it off about there. I'll cut the remaining bit off in a sec. So on this bit here, it should be out here somewhere. There it is. And if we just bend it down, you can see it's quite long. So I'll just cut it off now in profile with the pad, like that. We'll just straighten it out somewhat. And we need a 47 to go back on there. So our cap wants to go this way, around. Now the thing that's going to make this one more challenging is this wire. Yeah, I think that's in approximately the right position. Positive thing with this is the pads are actually there. It is literally just that one on the negative side there where the... hang on. So I'm just going to reposition that slightly because it's a bit far down this side. Testing on continuity here. From the positive side, that cap to there, got a join, and from the negative side of the cap to the negative there, got a join. So yeah, that's okay. So the remaining caps for the A4000s have arrived. So these are 4.7 microfarad and 22s. They're quite a lot smaller, you know, that's the problem. The ones I had before were the same size as these 47s. And whilst you might be able to, well, I don't know, they are a lot smaller. I was going to say you might be able to mount them with hot air directly on top of the pads there. I don't like doing that. It's better if the pads are accessible. And it's just the ones with the red line, those are the ones I need to swap out. On this particular board, they don't look like they've leaked, but I can smell they have. That stinks. Fishy electrolyte smell. And we'll get that one off as well. Up, stuck back down again there. So, my whole perception of recapping boards like this changed when I did the Maymeister one, you know. Using two ions like that to remove the caps, it's so blooming quick and easy. It really is. The A1200s have got slightly more caps, I think, but I'm not worried about doing them. I think they're going to be easy. Anyway, you can see that is nice and clean around there. So the black band is the square edge which goes down here. You know, the side up here has got the little slices out the corners to indicate the positive. Yeah, one of these is cleaner than the other one. I think this one's the one that's pretty tidy actually. There's very little leakage around here. But they did need replacing. That is for sure. So, finishing up here now, let's get these 22s off. I'll clean up that pad in a minute. I might just get the fiberglass pen on it and coat that with some solder. Yeah, sorry you couldn't see the inside, but if I just tilt this, but you can see I didn't touch the plastic there and it's off. Yeah, lots of work was done to this board, but yeah, it's looking good. So had a new bridge, two new 245s there. I think I swapped that, I'm pretty sure I did. It's got a new one of those. Socketed up the real-time clock and did a battery mod there, and obviously fully recapped. Both of these 4000s were fully recapped. Yeah, there's very little needs even wiping or cleaning on this. I've left it in a pretty clean state already. There's just a few fingerprints and things here, not a lot. And again, everything has been tested on these boards, so serial, parallel, external floppy drive, audio. Measured all the levels around here to make sure everything is correct as well, voltage wise, and it is. And of course the fast RAM works. Zorro 2 is being tested. The only thing I can't test on these two A4000s is Zorro 3. It's the same physical connectivity there, I think, but yeah, I don't have any Zorro 3 cards, so yeah, Zorro 2 works out okay with the A2091. The RAM's detected, it boots from SCSI on both of these boards. And here's the other A4000 as well, so again, full recap and a full bill of health on everything. Now this one, however, does need a bit of a clean on the underside. It's got some mucky marks all over the underside of it actually. And a final test of the real-time clock on this A4000, that is the correct time and date. So the real-time clock is fine. And I have a correction in an earlier part. I thought one of the 4 sims was faulty. It just needed cleaning with a fiberglass pen, that's all it was. All 4 work okay. Both of these 4000s had the odd pin bent. You can see I straightened them out pretty easily actually. I just literally used my probe to push it back into its channel, and then on 1 or 2 of them they'd been squashed down by somebody, so I used some very thin nose pliers and I gripped the end and just pulled it, which straightened out the bend that was in the surface of it, if that makes sense. So you can see they look good as new, and they've had cards in and out. This is the one where there were 3. There were 3 pins over here. In fact, you can still see them a little bit. Can you see here? That one there just sits a little bit higher. But you know what? I'm not going to interfere with them because they're good. So I packaged his Sims back up the way they came. I'll stick them inside a little jiffy bag inside the main box. I'm not sure if he meant me to keep these or what. He has sent me some CIAs. I'll show you in a sec. And here are the CIAs. So it's thanks to Stefan. Stefan arranged for this whole thing here. Very much appreciated. And I think he paid for half of these himself, actually, Stefan, and the other half a kind of like payment or part payment for doing these boards, which is amazing. I've never seen so many CIAs in my life. So we've got 1, 2, 3, 4, 5, 6, 7, 8. Is that 8? Yeah, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 CIAs. So yeah, Stefan kindly was thinking about me, following on from that A590 video where it killed 2 of my CIAs and it cost me £40 at the time. Now, since these have become a bit cheaper on eBay, I noticed a few sellers selling these for just less than £10 at the moment, but still, it's really nice to have a load of spare CIAs. I'm probably going to have to sell some of these, I think, to gain back some of the cost of the parts from this particular repair series and stuff here. You can see here, these just arrived today. I ordered these, a CIA and a Paul. I wanted some spares for myself, but as you'll see in the upcoming series, I'll need these to work out a problem with one of the really problematic boards. So I hope you enjoyed the first 2 parts of this series. There may be another 2 parts. I might even be able to wrap it up into 1. So we've got 4 Amiga 1200 boards coming up in the next video. You can see here, this is my new friend, Amiga being the word for friend. Yeah, so I have my own Amiga 4000 case now, as you can see. So this will be an upcoming video. We'll also cover a CPU accelerator card for this from Mr. Stephen Leary in an upcoming video, so that should be pretty interesting. But I've also got another A4000 motherboard here to look at, so this will be another repair. These are very samey though. One of the things you'll note, I've now got, I don't know, 4 or 5 Amiga 4000 repairs. Oh my goodness, look how dirty that is down there. Yeah, I've got 4 or 5 of these types of repairs on my channel now, and you'll see a pattern. It's the same sorts of things, you know, the corrosion spreads out here, you get problems with the real-time clock, predominantly broken traces around here. The wires here are problematic with the jumpers, which can stop it even booting, so that's one of the first things you should deal with. Mouse problems, real-time clock problems, real-time clock problems, real-time clock problems, fast RAM problems, and you can see this one's pretty bad actually compared to the ones in this video and the ones previously on my channel. Yeah, the SIM sockets may even need swapping on this one. Interestingly enough, it's got a 2 meg chip RAM there, that's good. SIM. Yeah, very dirty, lots of corrosion, but it's going to be much of the same stuff you've already seen. I'll post a link down below to some of the previous videos, because in this video you'll notice I fast forwarded through quite a lot of stuff. So in the previous videos there's a bit more depth, you know, to some of the things, removal of things and installation of things. Look around here, good God, that one's bad. Anyway, I do hope you found the video interesting. If you'd like to support the channel, please see the Ko-fi and Patreon links down below. $1 a month makes a huge difference to the continuation of this channel. I'd like to thank Stefan again for arranging for me to have a look at these boards, and obviously for Raj for, you know, trusting me to work on these. Thanks a lot. I'll catch you in the next video.